Um, Hi, I'm Wesley Turner. I work for the Kentucky Division of Water for their drone program and their GIS and data analysis section. We started our drone program a few months ago, or about 18 months ago, I suppose. And we decided that we wanted to try to start getting some aerial photographs for our dams for the dam safety program. Which is our primary mission right now. So our primary purpose is to provide programmatic support to any of the branches in the Division of Water, and also anybody in the cabinet. We've also helped several cabinet agencies as well. The primary purpose of our program is we collect aerial photographs for inspection purposes and for other purposes as well. We take those aerial photographs and we create orthomosaics out of them, which have GIS locational information built into them, so we can actually bring them into a mapping program. From that same information, we can build some 3D models and get an idea of how much material is needed to take out of in a dam construction, for instance. We can figure out what the cut and fill volumes are in particular areas. Transportation uses these 3D models for building highways and that type of thing as well. Our next area we want to get into is using multispectral data, like infrared and near infrared cameras, as well as thermographic cameras. We've flown a couple of thermographic missions, but we haven't had a chance to try out any multispectral data sensors yet. For our crew, we typically have 2 to 3 people on a crew. We have to have a minimum of 2 folks. That would be the remote pilot in command, which in case of Division of Water, I'm the only licensed pilot in command for the Division of Water right now, so I fly all the missions. I have to have a visual observer there with me, and that individual is responsible for making sure that no one comes into the area where I'm flying. There's no unexpected aircraft in the area or unexpected obstructions that I might run into that I don't see. And just to maintain the site, since I'm concentrating on the drone flying it and maintaining the proper altitudes and the like. Then we also have data processing staff, which we use a program called Pix4D to process all of our data right now. And there's a number of people in the division that's doing that right now. Then, of course, a key component to that is the management. We've got a very supportive management staff that really wants to see us continue with the drone program, and have really been supporting us a lot. There is an optional person, a person manipulating the controls. Those are for training missions. I can let people take the sticks on the drone and learn how to fly, but I have to be around them so I can immediately take control of the sticks if something starts to go wrong. So the person manipulating controls does not have to be a licensed pilot, but the remote pilot in command has to be a licensed pilot under Part 107 through the FAA. Just a little background on how our program started. We began in the spring of 2019 with our first set of missions, which was Bullock Pen up in Pendleton County, I think. Anyway, it's a dam construction progress reports that we do. I then obtained my remote pilot license in March of 2019. It's good for 2 years, so I've got a retest coming up soon. We fly missions. Right now, we're primarily flying dams, and we're starting to work with some wetlands delineation with it. And then we use the Pix4D software to process all of that data. We tested multiple platforms. We've used Drone Deploy, we've used Pix4D. Most of the drones that I've flown are DJI, is the company that makes the drones that we fly primarily. We have 2 primary drone types that we fly, and that's the Mavic 2 Pro and the Matrice, which is a much bigger drone. We started looking at documenting the QA/QC of our data in early 2020. because we were concentrating the first year on just getting the program started and trying to figure out exactly how to start flying our missions and collecting all of our data. And then we got to talking about, well, what are the quality parameters that we're using for our data? And so that's a question we started looking at, and we determined that we had to do a lot more research on that. We had to figure out what other folks are doing. So I'm working with multiple groups across the state with their programs and determining what the best QA/QC criteria are for any drone program, so that we're flying consistent data. Since we share it across the state, we want to make sure that the way we're collecting data and the way we're storing data is fairly consistent. This is the drone that I fly. This is called the Mavic Pro 2. And we flew it first because it was the first drone that we got. It's a very maneuverable drone. It's what's called a quadcopter. It has about a 25-minute flight time per battery. I have a series of 3 batteries, so I can usually get about an hour to an hour and a half flight time per mission. It's got a really nice camera. It's a Hasselblad 10 megapixel camera, which gives me some phenomenal resolution on the photographs that I take, and that helps when we start processing it into orthomosaics. It's got a 3-axis gimbal on the camera, so I can go up, down, side to side, and really get some really nice aerial photography done with it. Like I say, I had 3 batteries with a mobile charging system, so I can work for long periods in the field. Just as an example of some of the resolution that we get at 165 feet flight altitude, which is pretty average for what I fly most of my sites with, my resolution per pixel on the ground is 0.67 inches, which is better than any kind of aerial photography that we've got on any of our database layers in our GIS section. And it allows me to fly, I was able to fly 28.5 acres in about 24 minutes. Back when I was doing Superfund work, that I would have never been able to walk 28.5 acres and see everything I needed to see in 3 days probably. We have 2 different types of flight modes. One's an automated flight mode, where I can program in and repeat multiple flight missions. So if I want to look at the progress of a dam, for instance, like we're doing with Bullock Pen, I just continually use that same flight pattern each time, and it flies the exact same number of legs on the flight. It always collects the exact same number of photographs and at the exact same elevation, so I'm always comparing apples to apples. There's also a manual flight mode, which for some instances you have to use because there may not be enough clearance to fly on an automated mission. You may need to go up into river valleys or something, which really doesn't lend itself well to automated flight because it doesn't see trees sometimes. So we use a manual flight mode and record our pictures that way. The other piece of equipment that's essential to our operation is a GNSS, which is a global navigational satellite system. It's similar to a Trimble unit, or in our case, we use a Reach RS2. It's a fantastic unit. I can get sub-centimeter accuracy on lat long and elevation. It's got a built-in 3.5G modem, but now we actually connect using a Wi-Fi modem that's a 4G, so we get better connection. And we use the Kentucky Core system for our triangulation. There's a ReachView app that uses that you use with the unit, so that you can go out and collect all your data points. You name your data points. You can put any type of comments that you want to in it, and then it creates a CSV file, or you can export a shape file that tracks where all of your points are. So it's really good about bringing back into the field, so that you can, from the field and to your GIS programs, and you can import those shape files and know exactly where you took your readings, which helps you tie your orthomosaics and your aerial imagery to the earth. And then, of course, it sits on a bipod, You also have to have some type of tablet or smartphone since you have to use the app. We happen to use right now we're using an Apple iPad, and we're testing out Android to see how it works. The other key component is as you can see underneath of the unit there's an 18-inch square black and white set of triangles on a background that's a high visibility background that we can see up to 400 feet in the air. We can see these targets, so that as we're flying the mission, we leave these targets in place after we've surveyed them in, and then that gives us tie points that we can use for QA/QCing our data to make sure that everything's where it's supposed to be when we process our images. So we sat down and we thought about, well, how do we want to develop the program, and then eventually how do we want to start collecting our documentation on our QA/QC. First thing we did was we determined what the flight capabilities of the unit itself was. There's certain temperature ranges you can fly it in. There's certain altitudes that you can fly it at. There's certain wind conditions you can fly. Sometimes sunny days are better than cloudy days. So we had to figure out what all of those nuances were. And like I said, I had to obtain my Part 107 remote pilot license, which is a requirement for any commercial pilot, which we're considered commercial pilots. I flew multiple flights with other drone flyers in the cabinet and in state government. We've got a really great group of people that we work with. We've got folks from DNR, abandoned mine lands. We've got folks from transportation, and then of course us and folks from the Division of Waste Management. And we've all been working together to try to make consistent programs. Since it is all state data, we want to make sure we're all flying the same type of quality missions, so we can share data with each other as we develop these flight plans. We developed and documented some standard operating procedures for each individual piece of equipment that we use and each process that we fly. And then we also came up with some overall policies for the Division of Water pilots, what you can and can't do with the drone, that you do have to have a visual observer on site with you all the time, and some really specific activities that are prohibited from us, that are prohibited for us to do. And then also what the missions are going to be, what we're going to use the data for. I've been working with the Division of Waste Management and Abandoned Mine Lands to determine how we're going to best measure our QA/QC data for making acceptable data. Right now, we just we use the quality assurance report that comes out of Pix4D as our primary gauge as to whether it's good or not, but we're going to develop some very specific documentation for that. We developed, our intent is to develop those QA/QC standards for all the projects that we do. So in mission planning, we wrote this out into an SOP, and this is just this is what we do for each individual flight that we fly. And we always sit down and we document it. We've got a couple of checklists that have these components in them. And this is what we try to do for every single mission when we get ready to go out. If we start a new project, I always start by doing my mission planning, and I document everything, all my mission planning, what I've done, where I'm going to fly, what my airspace is, am I allowed to fly there? Do I have to get permission from FAA? Because in some areas you can't fly without permission from FAA. Are you allowed to fly there if the Corps of Engineers or any federal programs that won't allow you to fly drones across their programs? So you have to kind of get an idea of what all that is. And we document all of the mission planning so that as we go back, it's like any type of inspection that we do in the department, is we document how we did it, what we did, and why we did it. These are the pilot standards. There's really only one big standard, that if you're going to be flying by yourself, you have to have a Part 107 certification from FAA, and that's done with a national standard test that you have to go to one of the local airports and take, and it's actually a part of FAA standards. Then in our SOPs and our procedures, we require that any new pilot that comes on board, even if they do have their Part 107, is they need to fly with experienced flyers to make sure that they can control the craft properly and know how to plan a mission and know about the restrictions that they have to have. So we've got an educational program that we're sending our pilots through as they come on board. Right now we have 3 pilots in training, and that's what we're doing is we're giving them the documentation and the checklists, and then I'll be flying with them on missions to get them used to flying. In our SOPs and policies at the divisional water level, which we hope to take on up to DEP and EEC level, is that for a pilot to fly missions by themselves, in other words, be the pilot in command without another experienced pilot being there, is they must have 6 hours of stick time. And that just means controlling the entire mission, flying the drone, takeoff and landing the whole shooting match to make sure that they can plan the missions properly, that they can fly the machine without getting any kind of trouble. And if they do get into trouble, can they get out? We've got some training that we're developing right now, where we'll actually be taking pilots out to a drone park that we built last year and actually run them through the paces. And they'll have a checkout test that once they've got their 6 hours in, that they can demonstrate that they've got the capabilities of flying the drone. Because the big part of that is that the pilot in command is responsible for all aspects of the flight and the crew on site. So, for instance, if the drone were to fly off and hit somebody's car and cause damage, FAA does not look at the cabinet or the division. It's the pilot, the licensed pilot themselves that has the liability. So there's a lot of responsibility to this position. We don't take it lightly. And that's one of the things that we want to make sure through our documentation of our SOPs, which I think lends into our quality assurance of our flights, is making sure that everybody understands this is how you fly, you follow these procedures, and if anything goes wrong, you've got everything documented so you can demonstrate that you followed your procedures. Like I say, we developed a number of standard operating procedures. In this case, the only drone that we have right now is the Mavic, and I've got specific SOPs related to how to update the Mavic, how to maintain it, how to clean it, when it needs to be serviced, that type of thing. And that's all covered under their standard operating recommendations for their equipment. We just adopted their standards because we figure they should know what's going on with their equipment and how to best maintain it. There are some things that we have to make sure everybody understands, is that you cannot fly greater than 400 feet above ground level unless you're over a tower, and then you can add the height of that tower, like a water tower. If we were inspecting a water tower, you could go 400 feet above that water tower within a 500-foot radius. But you also have to make sure that you're not going to be in controlled airspace, because some controlled airspace starts at 700 feet. So you really have to know what all of those caveats are when you're getting ready to fly. Then we also have a set of conditions where we do not fly. If cloud cover is lower than 1,000 feet, we don't fly, because you can't fly within 500 feet of a cloud base. And we just make it as a 1,000 foot is the level that we don't have to worry about whether you're going to be within cloud areas or not. No rain or snow, because it's not good for the equipment, and can cause it to malfunction. Temperatures have to be between 30 and 100 degrees Fahrenheit. The machine doesn't do really well when it gets below 30 degrees. It makes the batteries, the motors work that much harder, which drains the batteries quicker, which also puts stress on the batteries and the motors. So we just typically don't fly below 30 degrees. Anything above 100, everything can overheat really quickly. And we always fly in wind speeds of less than 25 miles per hour. Anything greater than that, and the drone really struggles with maintaining its positioning, and which can really affect your photogrammetry. And then for our GPS strength, we require a minimum of 7 satellites to be visible on our equipment. It's just that way we know we've got good control, because this drone actually talks to the GPS satellites and wants to know where it is all the time. And so if you don't have a good connection, that's when you're likely to lose a signal and actually lose your drone. For our ground control points, we require a minimum of 5 ground control points, and this is for especially for the quality control of our photogrammetry. This is probably one of the most important aspects of what we collect, because without that, we don't know where the drone is, because it's taking GPS values, but it's reading at a different, it's reading at what's called an ellipsoid, which is not down on the earth. So we have to do some correction for that. And without our ground control points, we can't really correct that geoid to that geoid level. So we always lay out at least 5 ground control points. They need to be in areas where there's differences in elevation, surface slope changes, that type of thing. We try to make sure we can document those. If the site's really flat, it really, you can probably get by with 3 or 4, but we still recommend 5 just to be safe. That way, if you have any issues, you can exclude one of them. We use these 2 feet square targets that we've got there that we can actually see from the air and be able to determine where everything's at. Then we take a reading for 40 seconds. We put this device through 3 months of testing because we'd never used this particular unit. Most everybody that we know uses a Trimble unit. The Trimble units run around $26,000 for the unit. This unit was a little over $2,600, so it was 10% of the cost. And we decided to give it a try, and we've found it very comparable with anything that's on the market. It gives us sub-centimeter accuracy, and we ran it through a number of tests and combining it with 2 different Trimble units at the same time, and we were within 1 or 2%, which is pretty phenomenal. The important thing is the dilution of precision that's given to you by the screen that you're on the ReachView app. It needs to be 2 or less. Anything greater than 2, you don't have enough satellite coverage, and you can't really depend on the data being accurate enough, precise enough even. You have to have, we require a minimum of 6 satellites, because anything less than that, we really don't get a really good dilution of precision. So we try to always maintain 6 satellites. But as long as that DOP is below 2.0, we can sometimes use that data. We're just a little more suspicious of it. To give us the really accurate data, we connect to the Kentucky CORS system, which is a system of base units that are set all across Kentucky that are continually operating, and they're constantly checking with digital satellites and determining exactly their exact position on the face of the earth on a continual basis. And then the reach unit in this case talks to the CORS, and the CORS tells it exactly where it's at. So we're very precisely tied into where we are. We do have an SOP developed, and it's been implemented, and we've been using it for almost 18 months now. So it's been successful. The photogrammetry standards, that's the biggest area where we're going to have to continue some additional work. Currently, we use the QA/QC report that's generated by Pix4D, which is the software that we use. It'll tell you what your percentage of error and tell you how many of your points are outside the boundaries of its own internal QA/QC. And if it's great, if we lose more than 2 or 3% of our points, then we don't use that data, because that's what Pix4D recommends. What we want to be able to do is to develop specific programmatic standards based on certified and widely used surveying practices, for instance, and other photogrammetry software users. A number of states have adopted photogrammetry standards for their departments of transportation, and we're looking at those, and we figure if that's good enough for DOT, it should be good enough for us, because they depend on theirs for construction projects and maintenance of all their highways, and they require a very high level of precision and accuracy. So we're going to borrow some stuff from different states, which seem to have borrowed from each other. So we go ahead and we're going to just document those. And those standards will be vetted by multiple agencies across state government. We'll work with DOT, we'll work with AML over in DNR. We'll work with COT and make sure that what we're collecting is good for them. So we're going to work with multiple agencies to make sure that as we're implementing these standards, is that they're acceptable to the majority of the users, and it's going to give us the best data that we can possibly get. We started storing all of our data on a system called Box, and that's where we put our data and metadata that's related to the sites. The metadata portion of the standards aren't really established yet, so that's what we're really going to be working on, is determine exactly what type of metadata we need to capture to go with these individual flights. You know, do we want just pilot name and location and who are they flying for? So we need to get all of those standards worked out, and we've been working with COT and DJI to get those standards adopted, and so that's still in the works. And once again, that'll be vetted by multiple agencies to make sure it meets all of their standards as well. As I alluded to, we put everything up in what's called Box. It's a cloud-based storage, and we put everything in there. We have a designated naming convention for each of the projects and some of the products that we put into Box. We can store any type of information from the aerial images themselves to the orthomosaics that are created, but there's a specific image that they want to see in there. They've got a very specific way to name it so that they can go in and pull that out in a report and actually place that flight plan on a forward-facing map of all the flights that have been flown in the state of Kentucky. Any state agency that's flying drones to collect imagery should be putting this data out there on that Box system so that they can create that map. So that's what we're working with other state agencies, is to get them to put their data in and put it in exactly as everybody else, so that we're not having 15 or 20 different ways to figure something out. There has been an SOP developed for adding data to Box that was developed by COT and DJI, and we're all using that, and monthly quality reports run by COT. And if there's anything that comes up that doesn't meet those criteria, those individuals are notified to correct the data. We tried to get ahead of the game on this because as we start flying and more agencies starts flying, there's going to be a lot of data out there, and we really want to make sure it's the best data that we can get. So we've got several ongoing efforts. We're going to be further evaluating data accuracy and precision, like I was talking about, with making sure that the pixel images are proper and that we've got the proper parameters being given to us during our flights, that type of thing. So we're actually getting that, you know, what kind of level of accuracy do we need for the lat and long, and particularly the elevation. We're using sub-centimeter right now. I know our DOT uses 0.1 foot. So we need to make those equivalencies as well and make sure that everything that we're doing falls within that category and criteria. We're developing written guidelines for the collection and processing of the data so that it is consistent, and we can make sure we're all collecting the exact same type of data and same quality of data. We're researching the industry standards to make sure that the guidance that we write will be following within those standards. We're continuing education on flight procedures to ensure consistency. We have a monthly meeting with a users group. Right now we're doing it virtually, but sometimes we'll have as many as 70, 75 people in these meetings, and we talk about how we're doing our flights, and we kind of get good ideas from everybody. We've developed different programs from these meetings, and then this is also where we'll talk about our QA/QC standards with multiple members of the group to make sure that everybody's collecting the same type of data. And like, as I just alluded to, the standards will be vetted by multiple agencies to ensure quality. If you have any questions, be sure and contact me. You can reach out to me. I work in the Division of Water in the Watershed Management Branch. My email is at the bottom here. Feel free to contact me anytime, and I'll be glad to help you out any way I can. Thank you for your time.